This is going to be really, really fun. This is a no slides demo, so this is literally my only slide. You can find me, Rob Richardson, tweet me at rob_rich, and you can find the code that we're about to build on robrich.org. So let's head to robrich.org. I'll click on presentations, and here is Docker for the Windows developer, and you can click on this GitHub repo right here, which will get you to the code that we're about to build. So, right now it's a smidge stale because it's the last time I did it, but that's totally cool. While you're here, click on About Me, and you'll see a little bit more about things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. AZ Give Camp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. Next time you're in Phoenix, join us for the next AZ Give Camp. Or if you'd like a Give Camp in your area, reach out to me on Twitter or by email, and let's get philanthropy installed in your area as well. Some of the other things that I've done, SQL Source Control Basics. I was on the Gulp Core Contributors team in version 2 and version 3. One of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woohoo! So there's my claim to fame, my .NET Rocks trophy. Just kidding. So let's dig in. We want to build a Windows product using containers. So I've got Docker Desktop installed. I'm going to make sure that I switch into Windows containers, and let's create a new project. Here's a new project. I'm going to choose a web application. And in this particular case, I'll choose a .NET Framework application because we're on Windows containers. Let's pretend this is, I don't know, legacy Windows app. Here's an empty folder. And so let's put this here. We'll call the solution Net Framework, and we'll put it there. Okay, Net Framework 4.8. That's perfect. Yeah, let's build an MVC application. So now we have our application. Now, a typical Windows application will probably have a website, and we may have a backend service as well. So once this spins up, let's also go build a backend service. Installing Nuget packages is fun. Okay, so we've got Visual Studio fired up. Let's add a new project, add new project, and this one will be a Windows service. Now I did need to install the desktop workload for this to get the service to show up. Yep, Windows Service 1, that's perfect. Now we have our, for lack of a better term, our our legacy app. It does all the things that we want it to do. Here in this service, we may have a task. Let's, I don't know, delete this initialized service and the designer. We probably don't need that, but we want our application to do something. So let's say using system.timers, we'll create a timer, private read-only timer. Timer, and we'll set this timer equals new timer, and we will give it an interval of, I don't know, 1 second. Let's say enabled is false, and let's give it a callback. So timer.elapsed. Create that method. Oh, that's perfect. So every time the timer elapses, we can get it to go do the work. In this case, console.writeLine, let's say service doing work, and we'll give it date time.now.to long time string. So now our service is doing work. This is perfect. Now, right now it's set to enabled false, and it's enabled false on purpose because once the service starts, then it'll do it. So timer.enabled equals true on service start, timer.enabled equals false on service stop. Okay, so now we have a website, we have a Windows service. This kind of matches what we expect. Let's see if we can put this in containers. One of the rules of containers is that it will run one and only one process, exactly one process. Right now, this service is built to start up like, well, a service, a background process. And we would probably want to flip that over to be more the command that our Dockerfile will run. So let's do that. Instead of descending from service base, let's just say service. Now we don't have this override, so let's just say public void on start and public void on stop. Here in our program.cs, we can't do all of this service base run thing. So var service equals new service 1 and then service dot start. And we need to pass in a new string array because, well, that was the arguments there. In time, we might choose to remove that. And then we need to get something to keep this process alive so that Docker knows that it's still running. So while true thread dot sleep 1000, we could output something like still running or whatever, but yeah, that gets it done. We've now converted our process, our service, to a console app. We might choose to come in here to the properties and flip it from a service to a console application. We may choose not to. It works either way. But now we've got our application that is going to run with a single thread on the primary process. So let's Dockerize it. First thing we need to do is we need to add a Docker ignore file. Let's add a new item. This item will be a text file. And this text file will be .dockerignore. And that is important that it is .dockerignore and not dockerignore.txt. Not that unlike a git ignore file, this then lists all the things that we don't want to copy into our container. Bin, obj, star.user, star.suo, the .vs folder. We might include other things, star.log, anything that we don't want to move into the container. With that Docker ignore file set, let's go build a Dockerfile. Now again, we're going to create a new item. This will be a text file and it will be Dockerfile. Now again, it's important that this is Dockerfile and not dockerfile.txt, because this will be the definition for Docker that describes how we build this process. We can come in here to the properties, and for both the, I lost it. Oh, it renamed it dockerfile.txt. Let's rename that back to Dockerfile. Yes. Okay, so here in our Dockerfile, we'll say from. Now we're going to stand on the shoulders of giants, so let's create a base container that is that Dockerfile. So I'm going to head over to Docker Hub. Browser. There we go. I'm going to head over to Docker Hub and hub.docker.com, and I'm going to type in .NET Framework. As I hit .NET Framework, I land on this page that shows me the various repositories for interesting things. So samples is really cool. That has lots of different Docker files that I can use. Runtime, ASP.NET, SDK. Well, I'm going to build in this container, so let's open up the SDK one. So the .NET Framework SDK tells me that I need to Docker pull this container name. And now this is for 4.8. So, and my application is on .NET Framework 4.8. That'll be perfect. So from Microsoft. Okay. So now the next thing is we need to copy in everything from our current directory outside the container into the current directory inside the container. Now this first directory outside the container is wherever we run the Docker build command. This one inside the directory, let's set that. workdir to, I don't know, let's make up a directory, src. Perfect. So we've copied it in everything, and then let's run ms build. And we'll say something like net framework.sln/p configuration equals release and /m, so it'll run on as many cores as we have. Perfect. We've just built this solution. Well, before we do that, we need to run Nuget Restore so that it can restore all the Nuget packages. Well, right now, if we make any code changes, it will copy this layer in, then it will Nuget Restore, and then it will build. We probably want to include our Nuget packages in an earlier version, so let's move that up here. But now we do need to copy in net framework.sln into the current directory. We need to copy web application 1.csproj into the web application 1.csproj. So we're just copying that file into place. Let's do a similar thing for the Windows service one. And then we also need this packages.config. So let's go grab packages.config. That tells us what content we need to copy into place, or what Nuget packages we need to restore. Okay, so we've copied in all of our manifest. We run Nuget Restore. Then we're going to copy in everything else except for those things excluded from the Docker file, and then run the build. Next, we would probably do something like run nunit.exe. We don't have any tests in this project, but that's okay. And then we'll do something like, let's copy the results. That's going to be in /src/ Windows service 1/bin/release into the current directory. What is the new current directory? Workdir is, let's call it app. And then the thing that will launch as the container starts up will be Windows service 1.exe. Perfect. Now, if we were going to do nothing else to this Docker file, that would be completely sufficient. This does all of the pieces associated with our application, but right now we're deploying our source code as part of our build. So let's do that a little bit differently. Let's come back over here. We'll come here and we'll look at, oh, the .NET Framework runtime. That's perfect. Here's the .NET Framework runtime, and it specifies a different container. It's only slightly different. This one says .NET Framework SDK, and this one says .NET Framework runtime. So we've got the .NET Framework runtime. That's perfect. We copy in all the things, but we're no longer copying it from our host directory. Let's copy this from equals build. Well, where is that build container? Well, let's tag this one as build. What that says then is this is my build server, for lack of a better term, and this is my production container. Here's my production container down here. So I'm building two separate containers. I'm going to throw away this top one as soon as I'm done. That's totally fine. But then I've got this bottom one that only has the runtime and my built executable. That's perfect. So let's fire up a command inside this directory. Hey, give me my machine back. Windows is going to take a nap. Okay. CD desktop, CD docker, CD net framework. Okay. We want to Docker build. We're going to pass in the build file, which is Windows Service 1 Docker file. And we want to build out of the current directory, so the last dot. That will be our outside directory. Here's that process where we go build it. Now it's going to do all of the processes associated with a build server. It's going to do copy in all of our content. Here's that Nuget Restore. Then it will do a build. We've commented out our tests, but it could definitely run all of our tests and ultimately produce the final result. While that's building, let's go craft the content for this other piece. Nope, it's not going to let me. There we go. So we want to do a similar thing here. We're going to add a Docker ignore, a new item. This will be a text file. And this text file is a Docker ignore file. It's definitely not a docker ignore.txt. Bin obj star.user star.suo .vs. We also probably want to exclude in here the properties, not properties. Yeah, we'll come back to that one. Okay, and then a new Docker file. This will add a new item. This one will be a text file, and this will be Dockerfile. Now we want it to be Dockerfile, not dockerfile.txt, and it did it again. So let's rename that, and we'll take off the .txt. Yes. Now this Dockerfile got us really close, so let's copy that and we'll paste it into place and we'll get it started. All of the build process is great. We do want to do one more thing here though. We want to publish the web application. So let's publish this web application .csproj/configuration equals release, deploy on build, publish profile is folder profile. Okay, so how do we build that folder profile? Well, let's go in here and we'll say publish. Now I could choose to publish to Azure, I could choose to publish to, but let's choose to publish to a folder. That's perfect. That folder, bin app publish, that's fine. We just need to know where it is. And now I've got this folder profile. Back in our Docker file, let's look at this. And so instead of copying this, we'll copy web application 1, and then we'll go into bin app publish. So that's all the content that we want to copy into the current directory. We're not using this, we're using ASP.NET, and this will actually go to inetpub www root. Now the CMD actually comes in from the base container. It's IIS, and now we've got a second container ready to go. Let's take a look at this build and see how that worked. That was great, it built just fine. Docker run that container. There we go. Docker run that container. And now I'm able to, let's see if we can hide this actually. Nope. The system cannot find the file specified. That is interesting. Docker run dash IT that container. And let's see if we can go find out what that was. Ooh, it looks like we have a build failure. Build succeeded. I'm guessing I forgot to save. Let's go check. Here in this Docker file, Windows Service 1 bin release. Windows Service 1 bin release. Nope, I think that might be good. Let's save all just in case. Save all. And let's go build that other container. So docker build -f web application 1 / Dockerfile, and we'll build out of the current directory. This will go build the website. So now we're doing a similar process. Now we noticed that, oh, it didn't. We may get cached results here where we don't need to restore all the NuGet packages if we're just spinning up another web application. Because we haven't changed our code, the next time we build, all of these new packages that we're restoring right now will already be cached in Docker and will be ready to go. So we've restored some NuGet packages. It's going to copy in the rest of our application. We're running ms build. I really wish Teams would let me hide this. We've got our build succeeded. We're running the web application publish. We published our website. Copied it into the new container, and we're ready to go. Docker run. Now here, when we run this, can I move that? Nope. Docker run, we're going to want to pass some additional arguments because we don't just want to run. We want to, hey, give me back my command. We want to also forward some ports in. So let's forward in port 8080 to the containers port 80. We're going to go across the Docker network switch, and then we'll build this, or we'll run this, the thing that we just built. So it's going to spin up that website. It'll actually spin up IIS inside the container. And now if we go to our browser and go to localhost, now it's not actually localhost, it's running inside the container, but through the magic of Docker, it will automatically forward it off into the container, and that will work just fine. It may take a smidge to spin up this website, but that's totally fine. We're getting that IIS spinning up. The JIT compilation, there is our website. We got our service into a Docker container. We got our website into a Docker container. And that Docker file, there was really only 4 verbs that we really needed to worry about. From, where we talk about the base container that we're building from. Copy, where we're copying content into the container. Run, where we're running batch commands, batch file or PowerShell commands, whatever we'd like to do to be able to accomplish tasks inside the container. And then CMD, that specifies the runtime piece, the thing that will kick off and do all the things. There are other pieces that we definitely could set inside here, but that's the majority of the pieces. So we've got that Docker container ready to go. We'll just leave it going. Docker image or Docker container list, and we'll see there's that container running. Let's grab that container ID, and we can say Docker logs that container ID, and that will show us all the console output. In this case, there isn't any. That's totally fine. Docker inspect that container, and we can see all the particulars associated with that container. That's pretty cool. We'll leave that running. Docker container list. And let's step back here and we'll switch from .NET Framework to .NET Core. So .NET Framework is really cool, and that's fun to be able to build .NET Framework apps, to be able to move them into containers, and we saw how easy that was. Let's build an ASP.Core web application. Web application 1, we'll give it a solution name of NetCore. We'll make this MVC app. And now right here, we can see that there's this enable Docker support button. That's really cool. Let's leverage that going forward. So if we were to create a greenfield app, we could automatically get Docker support into our application. Now it does ask us to pick whether we're on Windows or Linux so that it can scaffold out the correct Docker file for us. Let's create that application. And similarly, we're going to want to create a Windows service. Now in .NET Core, new in .NET Core 3, we have a worker service template. Now this worker service allows us to do all the things that we did with a Windows service, but in this case, it's cross-platform. So it works on Mac and Linux just as well as it works on Windows. Here's that enable Docker support button, and so we'll leave that one checked. And now as we see the application spin up, not only do we already have our Docker file, we already have a Docker ignore file that is really interesting as well. In both projects, a Docker file and a Docker ignore file. Let's pop open that Docker file. Now this Docker file, I would argue, is a bit more complex than it needs to be, but we can see all of those same principles that we saw in there. We start with a base container, .NET Core, SDK 3.1, Nano Server 1903. If we wanted to, we could switch this up to 2004. We're going to copy in all of our manifest details, and then we'll run .NET build. We'll do a publish, and then copy in our final results so that we can kick that off into a website. That's perfect. Similarly, in our worker service, we do a similar thing where we copy in all the pieces. We're going to do a build, we're going to do a publish, and then we'll be able to run that worker service. Now, the one thing that we do want to do here with this worker service, here's this service that program.cs will start up, not that unlike a website where it builds in dependency injection, our inversion of control container, our IOC container, and it launches then this worker. Now we could add more workers if we want to, but here's that worker class, and it does all the pieces of, while we're not stopping, let's wait, and then it does some work. Hey, this worker service is running at this particular time. That's perfect. It's doing all the work that we need to. Now there's one more thing that we can do here. Here in .NET Core, because those Docker files are built completely for us, which is really neat, let's create a new file called a Docker compose file, dockercompose.yaml. Now this YAML file will allow us to specify all of the pieces of our application. Let's add an existing item into our solution. We'll go pick that dockercompose.yaml because it applies to both pieces. Version is 3.1, services. We're going to have a website and we'll have a service. In both of them, we'll say, I would like you to build. The context is the current directory. So, that's where we start building. And then the Docker file is web application 1/Docker file. That'll be the same mechanism that we'll do in the Windows service, but here it is worker service 1/Docker file. In the build, we also, during our run process, we wanted to expose a port. So let's say ports, and we want to say, I don't know, 8080 is already taken. So let's go to 8000. We'll redirect to port 80. And we can specify other environment variables to say, here's the environment variable that I want to set to this particular value. In this case, we don't need any, so we'll just leave that blank. Now this Docker compose file then specifies all of the Docker build commands and all of the Docker run commands that we need to be able to launch this application. Let's do that. Net core Docker compose up. Now Docker compose up will notice that we haven't built these yet, and so it'll build both of them, both the website and the service. So here's that first stop. It will go do all the things. Oh, it noticed that I built them previously and it just launched them. Here's our worker service doing all of the pieces. It's launching and running. We can then go to localhost 1000 and we get our .NET Core website. Our .NET Framework website is still running just fine. We are still running that container, but now we're also running this .NET Core website in a separate container. We didn't need to provision IIS. We didn't need to spin up any hardware. We didn't need to install Windows. All of that is handled by the container infrastructure for us. We created this one configuration as code file, and we were able to launch it into place. Well, now why would I do this instead of Kubernetes? Well, the cool thing about Kubernetes is Kubernetes begins with, so you have a Docker file, so you have a Docker container. And so we created this Docker file, we built this Docker container, and now when I'm ready to launch it on Kubernetes, I hand the same image to my Kubernetes cluster, and away we go. So for example, here inside Docker Desktop, if I go into settings, I chose previously to, where is it? I chose previously to launch Kubernetes. Oh, we're in Windows mode. And so Kubernetes is already running in my Linux side of this container. Well, we've got these containers running. Let's say Docker compose down, and that will take care of removing all of these containers, destroying all of that hardware. We didn't need to, I don't know, salvage all the things. We didn't need to unplug wires. If we now refresh these, we'll see that neither of them is running anymore. They are completely, the Windows service, the .NET Core Windows service is done. Let's go look for Docker container list. We see that we still have these other ones, so let's remove these. Docker container rm-f, that one. Docker container rm-f. Let's go turn off this one. Docker container rm-f. Let's kill this one. Docker container rm-f. And let's go kill this one. So we've now removed all of the containers that we spun up today. Well, that's cool. Now, what if I want to run this content on Linux? How do I get it from here to Linux? So I'm going to click on here and I'm going to say switch to Linux containers. If I switch to Linux containers, it'll say, hey, that'll take a minute. That's totally fine. Let's switch. Switching into Linux containers, I have that same Docker daemon running. I have that same ability to spin up containers, but now I'm running inside this really lightweight Linux virtual machine. In this case, I'm choosing to use WSL. So if I say WSL-list-v, I'll see that it's actually running inside this Ubuntu Linux virtual machine. Now I don't need to worry about that virtual machine at all. It completely takes care of it. Now, what do I need to do for my Docker file? Well, the only thing in our Docker file that is Windows specific here is this reference to Nano Server. If we were to use just ASP.NET 3.1, it would work identically. Or we could use Alpine, which is a really, really lightweight Linux distribution. Let's switch both of those to Alpine. We'll also switch both of them here to Alpine. I'm doing the exact same process, Docker compose up, and now here in Linux, it will go see if my containers exist. If they don't, it will rebuild them, and now we just spun up our thing. Here's our worker service that is running. Here's our website that's launched. And so now if I go refresh this localhost 8000, we see here's our ASP.NET Core website running inside of a Linux container. That's really cool. We were able to get an application running, both a legacy .NET Framework app and a brand new greenfield .NET Core app running inside Docker with not a whole lot of fuss. We just needed to work on those 4 containers, and now we can take that and launch it into Kubernetes. I have Kubernetes running here in Docker Desktop. So if I go into my settings, I'll see that Docker, nope, not Docker Engine. Here's Kubernetes. I enabled Kubernetes mode. So technically, these containers are already running on Kubernetes, and it shims that Docker Compose syntax into Kubernetes. I could now choose to publish these to Azure, to an Azure Container Registry, or I could do other mechanisms to get that content up into Azure or any Docker runtime to be able to use that there. So we saw how easy it was to build out a Docker file. We saw how powerful that was to be able to spin up hardware on demand. That was really cool. You'll find this code on robrich.org after this session. What are your questions?
Rob, I see one question which was there earlier. It said, is this a .NET framework or .NET Core that was used?
Good question. Our first example specifically was .NET Framework. Our second example was .NET Core, so we did one of each.
Okay. I hope this answers the question from a user. So that should be it. We don't have any other questions, Rob.
Wonderful. Some people ask me sometimes, let's go back to this other solution. I'm going to save that and go back to the .NET Framework version, but this same syntax applies. Some people ask me, why are we copying in all of the things? Couldn't we just copy them in all together and move this Nuget Restore back down here? Would that work? Yes, it definitely would. And it would, but it's a little bit less efficient. Now, if I change any of my C# files, I'll need to restore my NuGet packages. By copying in our manifest first, all of our CS proj details, and then running NuGet Restore, then copying all the other things, we can usually get a great speed up of build. So if we were to change one of these CS files, now the build could start here and use these as cache layers, which is really, really effective. Similarly, they're like, well, why are we doing all of this process with 2 containers? Could we just do it like this? Yeah, most definitely, that would work as well. The container image will be slightly bigger that way because I'm deploying not only the build tools, but also my source code into my production container. All else being equal, I really like lighter containers. So I'm going to spin up this second container that allows me to get only the pieces that I've built into place. So simultaneously, a similar question around this realm is, well, couldn't I just build inside Visual Studio and then copy this from my local directory, say, /bin/release into place, and then ignore all of this part? Well, we could, and that would definitely be an acceptable solution. At this point, we're not building inside the Docker container. We're building on our local machine and copying the results into the container. That would work as well. The downside to this approach, though, is we're removing that build in a neutral environment. Now we're getting the code that is on your machine. We're not doing all of the standard validation. We're not restoring the NuGet packages specific to the build system. So by having this build server, for lack of a better term, this build container that allows us to build in a neutral environment, we still get all of the benefits of a CI system. We get build in a neutral environment. We get to restore the latest versions of all the packages on our build server. We get to ensure that we only produce content if our unit tests pass, and all of those steps associated with building inside of a container. So then another question that we often get is, well, if I'm building inside of a container, do I still need a DevOps pipeline? Yes. In your DevOps pipeline, run that Docker build command, put that up to your container registry, and that ensures that the container is built in a completely neutral environment and matches your corporate policy about pull requests and auditing and all the other things. You probably don't want to Docker build from your local machine and publish it up to your production server. So these are some of the frequent questions. Are there other questions that users had as we wandered through this?
We don't see any questions right now, but I mean, since we still have time, everyone please feel free to put your questions in the Q&A section so that Rob can go ahead and answer it.
And as you're typing those questions, if you find that you want to reference this code, you can grab this straight off of GitHub. I'll push publish shortly after we hang up here. And if you find a question tomorrow, tweet me at rob_rich, and we can definitely continue this conversation. Either pulling in content into Docker and using that in Docker Swarm, or building these images and publishing them to Kubernetes. I can definitely help you with that as we get closer to.
We don't see any questions coming up yet, so let's give us a little bit of more time to see if we get some questions, Rob.
Okay, perfect. While we're there, I'll flip over to .NET Core. And let's see if we can clean up this Docker file a bit. Oh, that was an interesting error. It said my container is configured as Linux, but I've configured my application as Windows. There was one more piece that I needed to do in here. Default target OS, Linux. Let's do that in both places. So we really like that really simple container. Nuke all the comments. This is as base. Microsoft uses this mechanism inside Visual Studio to allow us to debug the container, and that is really, really interesting. But it does make the container a little bit more cloudy. We're exposing the two ports, 80 and 443. But here, let's do this. Let's copy in our manifest. So we'll copy in netcore.sln. We'll copy in web application 1.csproj into the web application 1 folder. Copy in worker. Did we have another question?
No, Rob.
Okay.
Let me check. Yeah, we have one question. The question says, is it more expensive to host a Windows container than a Linux container?
That is a great question. Comparing Windows and Linux containers. If we're running .NET Core, we have the ability to host in either. We can run in Linux containers or we can run in Windows containers. Generally, the Windows-based containers get to be pretty large. In .NET Core, we can run off of Nano Server, which is significantly less than other pieces. But Linux will be significantly less, will be even more or less, even smaller. That's a better way to say it. So in Linux, the Alpine container image is around 50 megs. The Nano Server one is 500 megs. The bummer part is as we get to .NET Framework can't run on Nano Server because Nano Server is 64-bit only and has no GUI pieces. in spite of the fact that in our website and in our Windows service, we weren't using any, GUI things. Part of the .NET framework is system.drawing, and system.drawing depends on GDI+, and GDI+ is a GUI component. So therefore, .NET Framework can't run on NanoServer. Because of that, for .NET Framework apps, we must depend on Windows Server Core. And Windows Server Core comes in at about 5 or 8 gigs. So 50 megs for a Linux container, 500 megs for a Nano server, and now we're up to 5 gigs. That's big. Now on the upside, once we get that image cached on our machine, on each production runtime machine and on our development machine, we don't need to pull that 5 gigs again every time. But it is large. So all else being equal, if we have the choice, I would prefer to run on Linux containers, but we have to first get from .NET Framework to .NET Core to be able to do that. Linux containers are generally lighter weight, and that just makes everything easier. That was a great question. So here we've done some interesting things with this Docker file to make it a little bit easier to see. We still have our base because, yeah, Microsoft needs it. But now we have a much clearer path to what we expect. Here's our build server, and it's doing the same processes, copying in all of our manifests, doing our .NET Restore. Now, in this case, I chose to copy in all of the other projects as well in case I have some class libraries that have some dependencies that we need. But then ultimately copy in everything else and build, publish, and then copy from that publish directory those things that we need into place and launch our application. All else being equal, that Docker file might be a little bit simpler to understand.
Yeah, we still have not received any new questions, Rob. So okay. Let's see. I mean, we still have like 12 minutes pending. So let's see if anybody comes up with the question by then.
Okay. One of the questions I often get here is, how do I integrate my unit tests into this process? How do I get my tests to run? And the cool part, we've just refactored this Docker file to be a whole lot simpler. Here's our build server, for lack of a better term, and we've just built everything. Here we can run .NET test. Now in this case, we don't have any test projects, so of course this is going to fail. So I'm just going to comment it out right now. But that's how we would run unit tests. And the beauty there is because we've got all of our tests running right in this step right here, we know by the time we get to this step right here, by the time we get to that publish step, all of our tests have passed. If at any time our tests fail, Docker build will stop here, and we won't get this final container built at all. So we add this .NET test piece, and we may need to then copy the contents of our run SCP, our test results, to some network drive, or perhaps we need to publish them through our build system in interesting ways. Some suggest that these could be great as build artifacts. I've also seen mechanisms where they map in volumes so that they can dump their build results into place. But that's the mechanism of how we get our build results then into our build server. One of the things that I really hope comes across in this is how easy it was to get started. There's only those 4 Docker verbs, and once we understand those, we can pretty much take any application, any .NET application, and get it into Docker. That was really fun. We got to get both a .NET Framework and a .NET Core app into place in a half hour. If I can do it in a half an hour, you can definitely move your application into Docker as well. One of the questions I often get is about licensing. Like, how do I license this? How do I license Windows? How do I license any DLLs that my application may choose to use? Now, the cool part is that when you license Windows, you're licensing the Windows kernel, the Windows operating system. And in a container, you don't have the Windows operating system. It's sharing that Windows operating system with the host machine. So you can run any number of containers without another license of Windows. Now, probably in your web server of choice, your ISP, they have Windows Data Center Edition that gives them the ability to host any number of virtual machines, and that license is completely sufficient for all of your containers. If you're licensing your components, Telerik components or Component 1 components or similar things, they like to sometimes license based on installs. And the bummer part is I am installing them every time I build. So to that end, you may run through your installs really fast. Work with your vendor to find a better way to license that component, or a site license, or most of them have gotten on board to understand that that license key that's used inside the container will work just fine. So they're not counting the number of times that you've installed it. They understand that in containerized environments, then it'll work really, really well. If you must get it licensed just so, then oftentimes there's a registry key or a license file that you need to copy into place as well. And once you copy that license file, then everything starts to work just fine. But that is one place where you may want to shy away from containers, where you have to very specifically license specific components registered in a very careful way. I would also argue it might be time to move on from that vendor. What other questions do we have?
We don't have any more questions, Rob. I think we are good. So again,
nice.
Thanks for this wonderful session. This was really very informative. And thanks for joining up for this course.
Well, thank you for coming. My name is Rob Richardson, and I had so much fun presenting to you today. Reach out to me on Twitter at Rob_Rich, and let's continue this conversation. Thanks for coming.
Thanks, Rob.